So following on from the previous video, we're trying to understand these transformations. If when you apply this transformation and it equals the original, then you can say it's symmetric along the x-axis. Let's try and understand what is meant by this. So if you have this, hang on, if you have, let's say you've got a point here where's an angle of, I don't know, pi over 7, and the radius happens to be, let's say, 3. So if you apply this transformation, so here it's currently, the angle is currently pi over 7. But for you to apply this transformation, it means you're putting the negative version of that angle into the function. So you're putting negative pi over 7. So you're putting this negative angle into the function, and it happens to be the same as the original. Well, the original is saying the radius of 3. So it's saying the original is saying the radius of 3. Now, if you put a negative version of the angle inside here, and it also equals 3 in our example, then it's going to be then it's going to be symmetric along the x-axis. So for example, let's say this point here, the angle here is, I don't know, let's say pi over I don't know, 3 here, and let's say the radius here is 5. The radius here is 5. So now when you put in the negative version of that same angle, so it will be pi over 3, say, then it gives you the same radius. So it gives you the same radius. So here the radius is 5. So there you can see it's symmetrical along the x-axis. So what this is saying is that if you put the negative version of the angle into the function, then it gives you the same radius. Now, if it gives you the same radius, then it can only mean it's symmetrical along the x-axis. Okay, I will explain this in the next video.